This is the fifth video on trigonometry. We're going to have a look at how we can use what we've seen so far to find out some further exact values of the trigonometric functions. So, if I am told that sine of an angle, here it's A, is 1/4, and I'm told that A is obtuse, so it's an obtuse angle, I want to find the exact values of what cos of that angle would be and what tan of that angle would be. Now, there's a couple of different ways that you can do this. First way, I'm going to go back to where we introduced our first definition of sine, which was that it's equal to the opposite side divided by the hypotenuse of a right angle triangle. So if I have a right angle triangle here, and this is my angle A, then if sine A is 1/4, that would mean that my opposite side is going to be 1, and my hypotenuse is going to be 4. Now, based on that information, I can work out the adjacent side in this right angle triangle just using Pythagoras. So 4 squared is 16, 1 squared is 1, take them away, get 15, and square root it. So I get root 15. So I've got all the missing sides in this right angle triangle. So I can now say that cos A is going to be, so cos is the adjacent divided by the hypotenuse, so it'd be root 15 over 4. Now, there is some information in this question I've conveniently neglected at the moment, and it's this. I'm told that A is an obtuse angle. So actually this diagram I drew here wasn't quite correct. However, it's not too much of a problem because, as we've seen in the previous videos, we have symmetry in these functions. And we've seen that within the graphs. So if I, let me just sketch out what the cos graph would look like. So cos is looking it's roughly like that. It should be going through 270, but roughly like that. Now, from the symmetry of the graph, I've assumed that A is acute at the moment, which is okay because I know that when it's obtuse, it's going to take the same values as when it was acute. It's going to give me the same values as when A was acute. However, it's negative. So all I actually need to do is stick a minus in front there, because I know that the cos function is negative when I have an acute angle. Okay, so that's the cos, that's the exact value of cos when sine is 1/4. Now let's do tan. So tan of this angle is equal to the opposite divided by the adjacent. So 1 over root 15. Now I can rationalise that. If I rationalise this, I will get root 15 over 15. And again, I need to consider whether this will be positive or whether this will be negative. I could sketch the graph out. My tan graph, remember, looks like that, where this is 90, that's 180, that's 270, and that's 360. So looking at this, I can see that when it's obtuse, when it's between 90 and 180, I can see that my tan graph is negative. So I can stick a minus in front there. That's one way I can do this question. However, I didn't actually need to draw that tan graph because remember from the previous video that we know that tan of an angle is equal to sine of that angle divided by cos of that angle. And if sine is positive and cos is negative, then my positive divided by a negative would give me a negative. So there we go. Let's have a look at a second example. So I'm told that cos B is 2/3. So draw my right angle triangle, and I know that my adjacent is 2 and my hypotenuse is 3. So that must mean that my opposite side over here, so 3 squared is 9, 2 squared is 4, 9 take away the 4 is 5, square root it, so my opposite side must be root 5. So therefore, sine B would be equal to opposite divided by the hypotenuse, so root 5 over 3. Now I need to check whether this should be a positive or whether it should be a negative. So let's think about what the sine function is when I have a reflex angle. Remember, reflex is above 180 degrees. So the sine graph, remember, looks like that. 180 is here. And I can see that whenever I've got a reflex angle, whenever I'm above 180, over there, it's negative. The sine graph is negative when I have a reflex angle. So I'm going to make that minus root 5 over 3. Tan. So tan B, that's going to be the opposite divided by the adjacent. So root 5 over 2. Now I need to think, is that going to be positive or negative? Well, if sine is positive and if sine is negative and if cos is positive, then my negative divided by my positive would give me a negative. So tan is going to be minus root 5 over 2. Okay. In terms of the graph for this, if I was going to think of this, how can I work out the sine graphically for this question? So drawing my tan graph, looks like that. Now, when I have a reflex angle, so that's above 180 degrees, initially I'm not sure whether my tan would be positive or would it be negative. Because reflex just means it could be anywhere in between these two. So it could be in this section, in which case it's positive, or it could be in this section, in which case it's negative. Now, in order for me to figure that out, one possible way I could do it is to go back to the original question and have a look at the cos B. Because I know that the cos of that angle is positive. I know the cos of the angle is positive. So, if I now add on the cos graph on here, so again, I'm looking at when it's reflex. So the fact that cos is positive that means I must be looking at this part of the graph, because that's where cos is positive. Not here, cos is negative down here. So because I'm looking at this part of the graph, I know that my angle B must be above 270 degrees, and we can see that tan is negative at that part, which is why I've got that minus there. So there's a couple of different ways of figuring out the sign of your trigonometric functions. If you want an alternative way of figuring out how to get these exact values rather than drawing a right angle triangle, just let me know in class and I'll show you a slightly different way of doing that. One last example. This question, I'm told that tan x is equal to p, and I want to find expressions for sine x and cos x in terms of p. So it's set out a little bit different to the two previous examples, but it's actually exactly the same method. The only way it's more complicated now is it's not telling me an actual number here. It's not telling me that it's equal to 2/3 or whether it's equal to 1/4. It's equal to p. But I can still use the same method. So I'm going to draw my right angle triangle. And I'm going to say that this is my angle x. Now, so tan is equal to the opposite divided by the adjacent. So I can imagine this as being p over 1. So that would mean that my opposite side is going to be p, my adjacent is going to be 1, and that must mean that my hypotenuse here, so square the 1, so 1 squared is 1, p squared is p squared, add them together, so I've got my p squared plus 1, and then square root it. So square this, add them together, square root it. So therefore, sine x, opposite, divided by the hypotenuse. In this example, notice it's not telling me whether x is acute or obtuse or reflex or anything like that, and I don't know the size of p either, so I'm not going to worry about putting a minus or I'm not going to worry about the sign in front of this. I'm just going to leave my answer like that, because the question asks me to get sine x in terms of p, and that's exactly what I've done. And for the cos x in terms of p, well, the adjacent is 1 and the hypotenuse is root p squared plus 1. There we go.